thank you everybody for being here. Today we're gonna show a live demo of Bauplan plus Claude Code. We are gonna work on like data quality on top of a pipeline that we also build with Claude Code. And so feel free to interrupt Shiro and me anytime that you want. You can use the chat, you can use the QA section. The structure of the webinar is the usual, meaning that we're going to have a very quick introduction with a couple of slides. Shiro is going to show us a live demo, and then we're going to take a final like 10-15 minutes of Q&A. Shiro, floor is yours. Guys, please have fun. Interrupt us anytime that you want.
All right. So I'm going to share my screen. So this should be, can you see the screen? Okay. All right. So very quickly, we're going to do like a little bit of introduction to the brand. Then we're going to jump into demo because I think it's like much more interesting and fun to do. Essentially, this is a webinar about mostly how to deal with problems of data quality. And it's at this point, like we're very interested in pushing as much as possible the usage of something like Claude Code or Cursor, like your AI coding agent, to take over some of the typical tasks and problems that as a data engineer you have to face, and see how much we can automate or just like augment the abilities of an AI and of a data engineer. So data quality is one of the biggest problems that you have as a data engineer. It kind of like bugs you for your entire career. I tend to think of data quality in kind of like two main big buckets. Like one is when data quality is a problem because it breaks stuff. And you have like pipelines or ETL imports that break because there's something wrong with the data that is ingested or processed. And these are like very explicit failures. The other bucket is kind of sneakier, and is drifting data. Usually some pipeline or some job where things are not immediately wrong. The pipeline runs to completion. It seems okay, but there's something wrong with the data. So there's data, kind of like drift away from being correct. And so the problem manifests more in like the numbers are wrong. The dashboards no longer represent what the business wants to see, but it's harder to catch. Like there's no traumatic event. There's no moment where the pipeline just like blows up, right? So today we're going to talk about only the failing jobs, and then we're going to have actually a next webinar on the more kind of like the sneakier and harder problem to figure out, which is the drifting data. Breaking pipelines is unfortunately one of those facts of life that is kind of hard to get rid of. Typically, you have like transformation pipelines that go from ingestion to consumption. A pipeline is usually just like a DAG, so it's basically a bunch of transformation steps that go in one direction. Sometimes things break, and downstream consumers are impacted by these problems. One of the problems with stuff like data quality is that like when something breaks, like it's not necessarily clear why. So there's a good deal of debugging and understanding of what happens. Like it can be. Most of the time is actually some kind of upstream schema change in my experience. There's some upstream producer of data that does something unexpected and that kind of like trickles down. But it can be, like the API has changed, the schema has changed. There's maybe some tests that we could have had in place to catch the problem, and we didn't. Maybe somebody changed some code at a certain point in the pipeline. So it's kind of unclear where things break. So what we're going to do today is basically go through the pipeline that you see on the slide right now. So we have some raw data, which is the infamous New York City taxi data set. So we're going to import a few gigabytes of that data set as a raw table. We're going to do an intermediate table, which is just a simple join with that data with some geospatial data. And then we're going to do like a simple aggregation that produces us a final table that is like the top location in New York City by number of taxi rides or something like that. And then like, in a real case scenario, that table will be consumed in a BI tool or in a visualization tool. This breaks for a data quality problem. We don't know in principle what it is. And what you typically do as a data engineer is you're going to have to analyze, so understand where the problem is. So go through logs, data, your code, try to figure out where exactly the problem is, fix it, and then ideally future-proof it. So like once you fix it, you kind of want to introduce like new data quality tests that prevent something like that from happening again. And the question here is, can we ask Claude to do this for us, like instead of like doing this manually all the time? The answer is yes, but as we always say, the problem with your coding agent today with data is that it needs certain ergonomics from your infrastructure in the cloud that platforms today do not offer, and that we built specifically for this purpose. The first one is isolated data branches. We want the agent to when the agent tries to fix something, is going to change your data. So we want to make sure that the agent is isolated so that anything that the agent does on your data does not impact the tables that other downstream consumers are reading from. You will want to have a way to give Claude Code some structured feedback, so a very API and code first design of the platform, because like the agent is very smart if you tell the agent everything that you know. So the logs, the context, the infrastructure, the data, the schemas, the errors, like everything goes back into the context. There's a lot that we can ask Claude to do for us. If that stuff is not in the context, it's very limited. And finally, whatever we ask the agent to do, we should be able to bring it to production in a way that is similar to the workflow that we have in software with Git. So there's a merge that happens only when we're really sure, and we can always roll back.
Sure.
Yeah.
I think we have some sort of like a preliminary question that plays pretty well with the isolation. Say, how do I know that the AI agent won't just like write bad checks and push them to production?
You don't. So the short answer is like you don't know that the agent will not do something bad, and our point of view on that is you should have a system that accommodates that fact. So you want to isolate the agent and you want to build guardrails around it so that the agent can be free to be the agent and do amazing things and sometimes silly things or wrong things. But the important thing is that whenever something wrong is done by the agent, it doesn't affect your production systems. So you cannot know in principle, but you can have a system that is robust to accommodate all that so that you can use automation without worries. Yeah. That would be my answer to that. Okay, so this is like how you should think of what you're going to see. So there's going to be a project. The project is local, as in like it's just a repository on your IDE. It runs on your machine. In that project, you will have files, your terminal, and you're going to have skills. Skills are markdown files that tell a coding agent how to deal with a certain, more or less complex workflow. And then you have your agent that calls, of course, like a model in the cloud, in this case, Claude. And then you're going to have your cloud infrastructure, which in this case is Bauplan, and that works like potentially you can talk with Bauplan with an MCP, or you can just like Bauplan is so simple that the MCP is not actually needed. You can just like ask Claude, hey, go on the documentation and just like read all the CLI comments. But we're going to use like the CLI and the SDK in this demo. But MCP is doable. It's very valuable when you have to combine Bauplan with other tools that maybe don't have a super strong support for the CLI. It's a separate conversation, but this is what you're going to see basically today. Yeah, let's jump into the demo. So let me see. Okay, let me start from this. So the first thing we're going to do is we're going to basically run a pipeline in our project, which is here. And what we're going to do is, see here, run that entire pipeline that I just showed you. We're going to run it like this. And that pipeline will take some data from from an S3 bucket, in this case, some gigabytes, a few gigabytes of data from the New York taxi data set. It's going to import that data into a data lakehouse. It's going to turn that into iceberg tables that now we can query and we can use to build new pipelines. And then it's going to run a transformation pipeline, which is right here, that does like a couple of things that are very simple, which is just, join this data with some geospatial data here, run a simple query on it, and then just like do an aggregation to give us like a top pickup location table. Problem is that this pipeline will fail, and will fail for a data quality problem. Okay, so this is what happened. So the pipeline failed. So first thing I'm going to do now is tell you, for instance, like let's use our UI, just simple. I have a job ID, which is the ID of a certain job. Here's what we're going to do is like, okay, this is a very familiar interface for everybody. It's just like a job page, and you have some details of what happened on this job that broke, right? So we have the code that ran. We have an overview of what the DAG should look like, and we have the logs. The logs are a bit cryptic in this case, so it's not really clear what happened, right? Now, all this is very familiar. And the other thing that is familiar here is, the data catalog. So we just imported tables. So I'm going to show you how, Bauplan looks like. It's a very familiar interface. You have just a bunch of tables in your data lake. The tables can be explored. You have your metadata. You have your data preview here. You can query the data if you want with an SQL editor. But there's one thing here that is very special, and is the fact that we have branches. So basically, we are now on main. You consider main your production environment, where all the tables that you see here are tables that should be trusted by other systems, by business stakeholders, by other, by downstream consumers in general. But you have so many versions of this data lake, and these are the branches. And branches are completely isolated from the main branch. Okay, and they look like, you should think of this as Git for your data. And as much as very much like Git, for every branch you will have a commit history, which will records immutably what happens on your tables and on your data lake. And it provides like a way for the agent we will see in a second when we have to debug or create like new data quality tests to really kind of like understand what happened and travel back and forth in time. The other thing is I can use this as a time traveling device. If I click on one of these commits, I can immediately go back into a previous version of the data lake that is associated to this commit hash. And that is very useful because we want the branch to isolate the agent, but we also want the commit history to make sure that even if the agent, even if something that we don't want that is done by the agent reaches production, I can roll back immediately and travel back in time to a previous version of the data lake where things were fine.
Ciro,
yes.
I think we have a very interesting question that can help everybody navigating, what you're showing. And it's like the number one question that also our clients ask us every single time we introduce skills. This is, okay, you have like a Bauplan, like standardized set of skills that you use in real life, or, am I supposed to customize, my skill based on my data model and da 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 da? I mean, the question was actually asked in a better way, and I copy and pasted to the chat, but that's like a summary of the question.
Okay. So skills, like, let me show you. It's like easier then. Skills are basically markdown files that live in your repository, and they will do things like, instruct Claude to build a pipeline or do some assessment about the feasibility of a pipeline, or the skill that we're going to see today, which is called the self-healing job, is basically telling Claude, hey, what to do when something breaks, and you want to fix it, and you want to add a data quality test after that to make sure that it never happens again. We provide those. Usually, they tend to be like the distillation of the work that our customers do. So, like at a certain point when, enough people do very similar workflows, they get standardized in the skills. So you can use our skills. So you're definitely not supposed to change anything. You're also not supposed to, as in like if you want to, yeah, totally. Like one of the beautiful things about skills is that they're just like markdown files, and so it's very easy for you to kind of like figure out if there's anything that you want to personalize. Having said that, since we're back into the IDE, why don't we ask Claude to figure out what just happened with our failing job? So we're going to ask Claude to do something like this. I want to check a job that did not run correctly, and I want to self-heal it. I want to know what went wrong, how to fix it, how to prevent from failing again, and for similar reasons in the future. And this is the specific job that we want. So with this prompt, now we basically let Claude loose to execute the skill that you see here on the right, on the left of the screen. The skill basically will go through that mental model that I briefly described before, which is, well, first you try to understand what happens. So for instance, like you pin the failing state, or you collect the evidence and you locate the root cause, right? And then you move forward to a phase where you want to apply a minimal fix. And when you apply the minimal fix, it's very important that you have that Git-for-Data abstraction that I was mentioning before, because that's where the agent will be required to change something in your actual data. And we want to make sure that that happens in an isolated environment that doesn't touch tables that are important for your downstream consumers. And then when, like we're going to run this again, make sure that the fix actually is effective. And when we're done, okay, we start thinking about future proofing. It's like how we make sure that this never happens again. So this is basically what the skill is going to do, is just instruct Claude to use a bunch of CLI commands and SDK APIs that Bauplan offers. Bauplan is very kind of like code first. And in that perspective, like you don't need much more than just like the skills and your API key and Bauplan installed in your IDE, right? So right now, like you see, like it goes like through all the different branches of the data lake, try to understand like what is the log from the runtime, and understand what the data is. As a general mental model for the root cause analysis, I know that this webinar is specifically on data quality, and the problem that we're going to debug is a data quality problem. However, when a pipeline fails, there are usually kind of like three main places where that can fail. It can be the runtime, it can be your infrastructure, it can be your code. So the runtime as your infrastructure, it can be your code, or it can be your data. Data quality usually is about the data, but in principle, you do not know. So this skill is general enough to basically instruct now Claude to say, okay, go and fetch all the context that you can, logs from the runtime, code, and data. So it seems that we have like an initial understanding of what happens. It says like the code is clear, the error is on line 70. There's a problem with a type. So it seems that something about the schema of the data that was imported is not right. Okay. So now in step 3 is collecting the evidence, which is what I was mentioning just a minute ago, going into the runtime, the data, and your code, and figure out exactly what happens. So it found it. It says like, well, there's a string type in taxi trip 2021. That should be an int. So there's a problem here with the mismatch of an upstream producer that just like abruptly changed the schema and broke our pipeline. It's a very common problem in data quality checks. And clearly we missed that because we didn't have tests in place, right? So once we have what Claude is doing in our local repository is it has created now a debug folder and is now starting to give us like some reports. So before moving into fixing, we want the agent to be able to tell us exactly what it found. So the first, we divided this report into, like, this is the problems that, this is all the information we could find about the runtime, so the execution pattern, but now is collecting also data evidence, as you can see here. So now he's looking into the data to understand, like, is this a problem with the code? Is this a problem with, I don't know, we ran out of memory, we had a different, a wrong package, or it's this about the data. So we have a classification here. There you go. So right now, if I go back here, I have also another snapshot that tells me this is what I found in the data. These are the tables that are involved in this pipeline. And these are the anomalies that I found. So yeah, it appears that we stored a string instead of a double, and that broke our pipeline. So now we have our report, and this is the first step, analyze. Now fix it. In applying a minimal fix, there's two main things that we need to do. The first one is we're going to create a new, we're going to now start to manipulate data, manipulate code. So the first thing, as you can see here, is that Claude created a Git branch. So for instance, in our pipeline file, which is here, we just applied this simple change to our pipeline, and this should fix the problem. This code change is separated from my main branch because we created a Git branch. But now we're running this pipeline, so this pipeline will create new data. Is that a problem? No, because now we're running this into also a data branch. So basically, in fact, if I go here and I search for this new branch, I can find it here. This branch was created a minute ago by Claude as a debug branch. And as you can see, has a very different common history from our main branch, which is our production environment. So essentially what is happening here is that we created full isolation. Every change in the code happens on a Git branch, and every change on the data produced by running that code happens in an isolated Bauplan branch. So we're good to go. Now, after we make sure, Claude actually, after Claude understands that, this is actually running well and we have green, both models succeeded, the pipeline runs perfectly, it seems that we fix it. How do we future-proof it? How do we add quality tests that would have caught this in a different scenario, right? So what Claude does here is going to add some expectation tests automatically. As you can see, the expectation test here is going to look like this. This is an expectation test that guards against schema drift. It would have caught this specific job. So in the doc strings, it tells you what the test does, why the test is there, and what type of problem is supposed to catch. And then it just added this test into our pipeline folder. So next time this pipeline runs, it will run with the change. After we merge the Git branch, it will change with the applied change to the actual pipeline and with new tests. And at the end of this, it will now create. It will commit all the changes in the code, and make sure that what has been run is all right. We can merge the data that has been produced by this run, if we want, using Bauplan, directly and promote the new tables into production. Or we can have, which is what most of our customers actually have, a little bit more articulated sort of data CI/CD process. At the end of this process, we also should have a final summary that Claude is writing for us. Thank you, Claude. You've been super duper helpful. And this is our final output. So we have hey, this is the job, this is the failing, this is a root cause model, what broke, why broke, what was fixed, determinism. Do you want to reproduce this deterministically? You totally can. You can travel back in time in both code and data. And this is what we did to prevent this. And this is the results for rerunning. So the final thing that we have from Claude is basically this final report. And we have now a branch in our data catalog that we can merge into main if we want, and a branch in our Git that we can merge into main. And this is how you kind of automate as much as you can from your process of debugging data quality tests and trying to prevent them from future failing. That would be
That's
my
great.
demo. This
That's
is the flow.
Great. We have some questions.
Nice.
So we have more or less, guys, 15 minutes where we can, take questions and chat together. So the first one is about like learning curve. I'm gonna copy and paste it here for everybody to read. And it basically says, okay, I love it, but what is the learning curve for my team? So am I supposed, to teach my engineers a completely different platform, or is going to be the agents like doing most of the job and writing like quality checks?
So I would say that so the learning curve with Bauplan is very low, and that is mostly because like the platform is built around on the one hand the idea that we piggyback on existing normal concepts of SQL and Python. So there's really nothing special about learning like writing Bauplan code. In fact, Claude can do that basically out of the box. It's just Python. There are some primitives of the platform that you will end up learning either by yourself or just like using the agent that are mostly around this branching system. So that's why we're a great believer in the skills. The skills, I think, like really help automating, important workflows, meaningful workflows for data engineers. And then, if anything goes wrong into your agentic usage of our platform, at the end of the day, Claude just produced a bunch of Python files, so you can go there and just like look at them.
Awesome. So we have a question here in the chat from Danny, who is basically asking a security question. So what information about the workflow is shared with Claude? It's just the code? Also, what other skills you're thinking of other than what other like skills we have available right now, or what other skills we are thinking, of the other than just like fixing the work. So these are very different questions. So one is about like skills in general, and the other one is about like security and code. And
so Claude will have essentially the security clearance that you decided to give it to, that you will decide to grant, because like Claude in this case is just using an API like any other user. So I would say that it will be like for Claude to be able to automate your work, it will certainly need to know about your repository and your code. And it will certainly need to know about at least like your metadata and your data, depending on what you can obscure in the answer. So there are like certain fields that you can just like make disappear because maybe they contain PII and you don't want them to go back into the context. But you should think of that as Claude reads the code in your local repository, runs the code, gets the data back, now understands the data and the code and cycles. How much of that data is visible to Claude? It kind of depends on the security clearance that you give Claude. As far as the skills are concerned, we right now we certainly have there are like some basic skills about the most important workflows that people do. One is what we call the quality gated updates, which is basically a way to offload to Claude things like, do you want to import a new table? Do you want to create a new asset? But before doing that, we want to make sure that you always do that into data branch and you run a bunch of quality tests before doing that. And that's just one skill. The other one that we have is build a pipeline, of course, which teaches kind of like the general way in which you build a transformation pipeline. We have now an increasing demand for specific skills about exploring data, assessing the feasibility of a project. Like a business user comes to you and just like, I want to answer this question. You want to ask Claude, it's like, do we even have the data for that? If the data that we have, is that usable? Is that fresh? Like, how should I think about like answering this business guy? And that is brand new. And then we have the self-healing one, which is the one that I showed you in this demo.
Awesome. So one more question I'm going to type here, and then I'm going to go back to the question in the chat, and then I try to juggle with both stuff on the chat and stuff on the Q&A. So it's about basically the size of the debug content that we want to provide to Claude. So do you commit in the code also the debug folder to let Claude Code read the reports in the future? Or did the folder grows exponentially for every bug fix? Does it make sense to commit such verbose markdown files?
That's a good point. Like, I think like my advice to that is just like you can actually use Claude to just like fetch these things from your GitHub rather than just like having all them like all the time in your repository. If you like, simple example of that, like in preparing this demo, I kind of ran this like several times, for instance, and like Claude is once it has it's very good at manipulating like your GitHub, your Git APIs. So it's able to kind of like go back and fetch what happened before it. So after a while, it goes like, this error is happening like a lot of times, and we already fixed it like several times. And that's because I was kind of like just like running the demo to make sure to prepare the demo. So like yeah, you should probably get that in your repository, but like tell Claude to fetch that only using like web search and things like that.
Awesome. Um, Let me move to this one, which is basically a question about like existing architecture and migration. Say, okay, does Cloud Code works with existing general data stacks such as like dbt core plus Airflow plus Databricks? What's the advantage or the uniqueness about like bringing Bauplan to this kind of like setup? Does it require data engineer team to migrate these existing stacks or tool or not?
Okay, this is a very good question. So there's two separate things. So the unique advantage that you have in using Bauplan is that Bauplan is built specifically for your agent. And so it is built in this way that isolates the agent at every single step. That's very much like the gist of it. So you can hook your agent to all the platforms aforementioned, but they're not really built for this. So like you kind of have to figure out yourself a way to make it secure if you want your agent to change the data. If you want your agent to just read the data, I think you're fine. Like, I mean, worst case scenario, you get like a report that is not right, like on the fly. But if you want the agent to run a pipeline, to write a new table, to integrate a new source, those are risky things to do. And Babylon is uniquely designed to make that secure for your agent. As far as compatibility goes, um, under the hood, what you just saw runs compute in the cloud and creates iceberg tables. And so the choice of using iceberg in this case is specifically because we don't want you to migrate from whatever you have. Like data migration are super painful, and like we definitely don't want anybody to go through that. For those who are not familiar with iceberg, iceberg is an open format, an open table format that is interoperable. So all the assets that are produced by Claude Code using Bauplan end up being tables that are in your object storage, always in your VPC, in your infrastructure, in your bucket, and they can be read immediately from Snowflake, BigQuery. They could like all the query engines out there today speak natively Iceberg. So we definitely don't want you to migrate to our infrastructure. So we built it to be interoperable.
Awesome. We have a new question from Dan. Thanks, Dan, in the chat, so everybody can read it already, which is more like a space-related question, which is, okay, with the space evolving, space like, the data space, like, or like, okay, so with the space evolving, what are the new capabilities in the horizon for the Bauplan MCP?
Okay, so Bauplan is a bit different than other platforms in this sense. Bauplan and the MCP are the same thing. Like everything that is available in the platform is also available to an LLM immediately. So there's really no disalignment between the two. The platform, like the capabilities we're working on these days are mostly around making sure that you can do more things in the context to allow your agent to be really aware of everything that happens in your data pipelines. And a good example of that would be data contracts or semantics. Like traditionally, you have a place where you define the semantics, then you have a runtime, then you have the sort. Like it's all separated, and that is a big blocker for something like Claude to be able to kind of like figure things out, because like all these things are in different places. And we're working a lot on ways to program this into the platform so that, for instance, like every step of your pipeline also contains a semantic definition directly in the code. So when Claude reads the repository, it reads like the transformation, the infrastructure, and the semantics. So now you can also ask Claude stuff like, hey, this pipeline looks all right, but does this table mean what we think it means? And it's very surprising like what the agent can do when you put like a lot of stuff in the context.
Okay. So next question is about again like existing like infrastructure in place, but it's more of from a functional standpoint than an architectural, which is okay, we already have like DBT tests for schema validation and like grid expectation for statistical checks. Where does this thing is gonna fit?
So that's actually a very simple design. So we definitely don't want to use like like whatever you like is definitely what you should choose, and we want to be compatible with everything. So your grid expectation test will live in your repository. Your DBT test will live in your repository. So Claude can read that. So if Claude want to use like a different framework to do transformation or data tests, can totally do that. Bauplan is the infrastructure behind the hood more than anything else. And like the important thing is that this stuff is in like my only point on this is like the important stuff is that this is somehow code. So if you use like DBT, super cool. If you use like grid expectation, super cool. If you use some different product that maybe adds a test through a UI, well, that's going to be hard for Claude to know that it exists, because if it is not in the context, it doesn't really exist for the model.
Awesome. Next one is more about like multi-cloud like capabilities. It is like, is Bauplan's feature set capabilities same across all cloud providers if we're using Iceberg like underneath?
So Iceberg per se like provides like a very interoperable base, but you still have to. So Iceberg is basically a logical table on top of Parquet files or CSV files or some kind of like columnar format in which you actually store the files. Those files will live in an object storage. So the object storage is cloud dependent. So no problem in moving the data in and out, but at a certain point we will like if we work with you, we will have to decide where to deploy Bauplan, if we want to deploy that in GCP or AWS, because your bucket will be an AWS bucket or a GCP bucket. Like it kind of depends, like, where your actual data stays. It's not terribly complicated to do multi-cloud things if the only touch point is the bucket, but you still have to move it. Like if you still have to move the data from one bucket to another if you want to do multi-cloud.
Okay. So I saved this one for for the end because it's kind of relevant to what we're gonna.
Do we have dark mode? Yes.
Yeah. No, I mean,
No.
I already replied to that one.
I
So,
always get that one.
So we have one more minute, and we're gonna answer to this one that is gonna, and we're gonna spend more time on this one, most probably in the future. And it's about what does this handles like slowly drifting data quality, like a column that's technically valid, but the distribution has
This is
drifted
our
over
next webinar.
weeks.
Yeah, absolutely. This is our next. Yeah, I understand. Like in data quality, that is kind of like the peskiest use case where like things like seem all right, and then you just get a Slack message from some business person who is not happy about the numbers. Yes, so tune in for the next webinar because we're gonna definitely do that. It ties back to what I just said before, as in if you start putting everything in code and everything in the context, and you use a platform like Bauplan that is designed to be quintessentially code first, you can tell the agent also to figure out things that are subtler like this. You can tell Claude saying just like, hey, like this table should kind of look like this. It should have like this min and max. You should have these statistics. If any of these things like look weird, let me know. So yeah.
Okay.
But it's like this is our next webinar. So let's do it.
So guys, if you think that this question is relevant to what you're doing, I mean, here is the QR code. I'm gonna send you the invite to everybody as well. So For today, thank you so much for joining us. And we personally had a lot of fun. Please reach out if you have any additional questions. We are always like extremely available, kind of like anywhere you can find us. Again, thanks again and see you next time. Bye, guys.
Bye, guys. Thank you.